Right, we learned about Eigrp Introduction in the previous class. We learned all these points. It's an advanced distance vector protocol because it maintains a backup path. It is fast in convergence. It's a classless protocol. It supports VLS discontinuous network. And Eigrp do not send periodically updates like we have in RIP as well as in OSPF. Even in OSPF there is periodic update. Even in OSPF there is periodic update every 30 minutes. Whereas in RIP every 30 seconds. Now we do not have such periodic update in Eigrp. That is seen as a positive thing in Eigrp because we don't consume bandwidth time to time in a big amount, and not only that, we don't necessarily disturb the other router sending the same updates periodically. Only the partial update is encouraged. It is sent using Eigrp. Eigrp uses only partial update. It will send only the changes that has happened. We also learned that Eigrp can be used with IPX, AppleTalk, like we use today with IPv4 and IPv6. So it has got different module for different network layer protocol. IP is one module. The Eigrp that you remember you enabled, right? That is IP module. IP module of Eigrp. Likewise, for IPX also you have a command. I'll show you. For AppleTalk also you have command to enable Eigrp. But we don't work with IPX and AppleTalk, so there is no need. As of now, there is no need. Next, flexible network design. Flexible network design, what does it mean? Eigrp supports any size network, small with 10 routers, 50 routers, 30 routers, hub and spoke topology, full mesh topology, partial topology. It supports any network design. Eigrp will not use broadcast because broadcast is bad. Eigrp's multicast address is 224.0.0.10. So only multicast address are used in order to talk to many, and unicast address is what used to talk to discovered neighbor. To unknown neighbors it is multicast, to the discovered neighbor it is unicast. Manual summarization, at any point we are going to see that in depth today. Manual summarization is nothing but interface level summarization. Global summarization is global. For all interface the summarization is applicable if you do global summarization. Auto summary, no auto summary. We used to type right. No auto summary. What it is? It is going to cancel the summarization on every interface on the router. Wherever Eigrp is enabled, on all those interface of that router, the summarization is getting cancelled. Whereas manual summarization is cancelling or enabling summarization only on one interface. Rest of the other interfaces are not summarizing. Only one interface. If you want to summarize, you may use manual summarization. This summarization configuration goes under the interface. We'll see this today. Next, Eigrp uses dual algorithm, diffusing update algorithm, which guarantees 100% loop-free classless routing. Dual diffusing update algorithm. Eigrp configuration is actually simple as configuring RIP Additionally, you will have an autonomous system number and wildcard mask if you need. Otherwise, it's same like RIP, not much difficult. This easy configuration is also same for WAN. Both LAN and WAN, there is no additional configuration needed, but for OSPF, if you take, you need some WAN considerations. You need to do some extra configuration for WAN links, especially when you have frame relay running. You'll have some extra configuration in OSPF to enable only for WAN interface. So comparatively, this is easier. Load balancing every routing protocol except BGP. Every routing protocol except BGP supports load balancing. Every protocol except BGP supports load balancing. But equal cost load balancing is what every protocol supports. What is equal cost path? We have multiple paths with same metric to reach some destination. Then it is equal cost path. Equal cost path. Same metric to reach a destination. Same metric via multiple paths to reach destination. That is equal cost path. EIGRP, one step more, it can support unequal cost load balancing. One path has got 100 as metric, another path to the same destination has got 50 as metric. Both can be used for load sharing. According to the capacity, the load will be shared. The one with the metric of 50 will be taking more traffic, because less the metric, better the bandwidth. And the other one, which has got 75 as the metric, that will take a little lower amount of data. Now, some key technologies to know about EIGRP: neighbor discovery and recovery. You see, if you want to form neighbor with someone, first thing what you do is you go and say hello. If you go to Kerala, you may be walking on the road. I don't know whether it is still seen. I'm talking like 25 years before, when I was a teenager. When I walk in the road, everyone will smile and say, where are you going? They will ask this question as if they are relatives. They will ask like this. Okay, one more example. Even today, if you go to Nigeria, when you see someone, they will ask, how far? Pardon? How far? Maybe Sriram will be knowing, because he is also from the side of African country. He came now. How far? They will ask how far. Means how far you have prospered in your life. How things are going. That's how, they ask. How far? Whomever you meet, they'll I was like, who is he asking me how far? And then I understood it's a way to greet in Nigeria. How far? That has become a greeting, like we say good morning, good afternoon. Here they will say good morning and then how far. They will not ask how are you. They'll ask how far. Likewise, EIGRP will say hello. Using a multicast address 224.0.0.5. Sorry, 10. 224.0.0.10. Using a multicast address, hello packets are sent. Now any packet sent to this address can be heard by all Eigrp routers. So if there is any new router there, it can now learn the neighbor when this hello has come. When the hello reaches this router now learns that neighbor. Likewise, when this router sends hello using that same address 224.0.0.10, that router can hear and learn. In short, it is the hello packet that helps to discover neighbor. Hello packets are sent every 10 seconds. Is it true? No. 5 seconds. Hello packets are sent every 5 seconds. This hello packets only helps to discover neighbor. Anywhere you go in the road, if you want to form neighbor, first you say hello only. They also say hello. And then if you like, you continue talking to them and form neighborship. But everything begins with one hello. Likewise, if a neighbor is dead, if a neighbor disappears for a long time, and when he comes back, he says, hello, how are you after a long time? Yeah, I went to London to see the Queen. That helps to recover the neighborship now. The same hello. In Eigrp also we have the same procedure. Hello is what going to recover a neighbor who is lost. Discovering neighbor, recovering neighbor is using hello packet, which are sent every 5 seconds. Now after forming the adjacency, meaning after they say hello and share the update and form adjacency, they don't stop saying the hello. These routers keep sending hello every 5 seconds. If any neighbor fails to say hello for 10 additional seconds, meaning 5 plus 10, 15 seconds. For 15 seconds, if a neighbor did not say hello, that neighbor will be considered dead. If any information from that neighbor which is learned earlier will be thrown out. So neighbor discovery is using hello packets. Timer is 5 and 15. Next. See, this is not a TCP based protocol. I'll capture and show you now. It's not a TCP based protocol. So to provide reliability, there should be something, to guarantee the delivery of all BGP packets to all the neighbors. There should be some packet sent to give guarantee saying, hello, I got your message, thank you. Only then he will be in peace. Oh, I sent him, whether he received or not, will be the confusion till he gets the acknowledgement. So there is need for some acknowledgement. There is need for some reliable, guaranteed communication, for which there is a small algorithm called RTP, a small protocol called RTP, Reliable Transport Protocol. Packets are sent. RTP packets. This is not real-time protocol. Real-time protocol is voice packets. Real-time RTP. That RTP is different. This is Eigrp's RTP. Next. Dual finite state machine. What does it mean? As I said earlier, dual is diffusing update algorithm. This used to diffuse. Diffusing update algorithm, what it diffuses? You may have many paths to reach a destination, but not all paths are good. So dual algorithm will pick those good paths. In that good paths, it will pick one best path. And best path, it will put it into the routing table. What about the other good path? It will put it into the topology table. Why they are seen as good? Because they will not form a loop. A loop-free paths are selected, among which one will be elected as the primary, or one or whatever the low-cost path will be elected as the primary. The other path, which is also considered as good but not lowest in cost, will be seen in the topology table. That good is determined based on the loop freeness. For the dual algorithm, we'll use a condition called feasibility condition, which we will be talking later, using which it knows that this path will cause loop, this will not cause loop. So when some paths are found loop free but not with a low cost, loop free but not low cost, those paths are kept in the topology table for backup purpose. Loop free low metric will be seen in the routing table. Loop free little higher metric routes will be considered as a feasible successor, will be there in the topology table as a backup path. Backup path is what called as feasible successor. Successor, I don't know, the people take in different meaning. Successor means my son is my successor. That is what they used to say. My son is my successor. But that is not the meaning here. Here, successor means the elected one. Elected route is a successor. The best route is a successor. Feasible successor is the one like a son. After the primary path, the backup path comes as a picture. So backup paths are called as feasible successors. Successor meaning is not after father, son. No. Successor means elected one. But in India, many people say, I have heard saying, he is my successor. What meaning they convey is, after me, he will come. But that's not the word meaning successor. Successor means elected one. Elected one. It's not after me. He is the one who is going to be there in the throne. That is what successor means. He is the one. So successor is the best route, the elected route. Feasible successor is the backup route. After me, whoever comes is the feasible successor. That's how it should go. Alright, next. That's the responsibility of dual algorithm. Dual algorithm is to pick a low cost path, a loop free path for every destination. This last point we have already spoke. Protocol dependent module, meaning for every protocol, network layer protocol, there is a module which you need to enable. For IPX, you need to enable the IPX module of Eigrp. For AppleTalk, you need to enable the AppleTalk module of Eigrp. So you have a separate. You have every network layer protocol depends on its own module. Each module is independent from one another. Each protocol has got its own Eigrp module and operates independently of any of the other that are running. So you may run one router with both IP Eigrp as well as IPX Eigrp. They are independent. They won't disturb each other. EIGRP maintains three tables. One is the neighbor table, where you will have the neighbors with whom the hello packets are shared and received. Updates are shared and received and formed adjacency. Directly connected neighbors, either physically or through tunnel. Now, to understand the other two tables, like topology table and routing table, we need to understand this page. I just want to break this into simple way so that you will not waste much time in this. You see, the terminologies are like this. Advertise distance. What does AD means here? Not administrative distance. Administrative distance of EIGRP is 90. We learned yesterday. That AD is different from this AD. This is advertised distance. Advertised. If you are from west, you take it as Z. If you are from south, you take it as S. That's why I draw a neutral in between. Advertised distance. Feasible distance. Successor. Feasible successor. Yep. Feasibility condition. Total distance. So these are the terminologies that we need to understand now to understand EIGRP better. Let us see them one by one. You see, I got a router connected to another router, connected to another router, connected to another router. And I got only one router connected to this router. Fine. Just for our understanding, I am doing this. Oh, this is not under the recording area. Let me bring it down. Now let's say we got a network here called 7.7.7.7. Now here 1.1.1.1. Let's say the metric on each link is 10, for example. Now this router will advertise saying, I got route to reach 7777 in my routing table, and the cost to reach is 10, 10, 10, 30. And this will advertise saying, I got 7.7.7.7. The cost to reach is 20. Now let me call this as A and this as B. And this is K. For K to reach 777 via A. via A via B. Via A, the advertised distance is via A, the advertised distance is 30. This is what called as advertised distance, because it is advertising, no? A is telling for me it's 30. B is saying for me it is 20. That is why we call it as advertised distance. It's coming through the advertisement. But is that the metric for K? No. Metric for K is this 30 plus this 10. That will be 40. We call this as feasible distance. Now 20 plus 10 is 30. These are the two feasible distance we have. You can also call it as total distance. But some people, they confuse you because they are confused. What they confuse you, no? Allah kadad. Not like that. It's like this. This is total distance only. This is feasible distance. I don't know which book they read. Feasible distance is total distance. Now this is successor distance. Successor. What is successor? The path via the metric is lower to reach the destination. For K to reach 7777, going via B is successor route. This is the successor value. 30 is a successor value. The shortest, the lowest feasible distance is what? The successor value. Now, this is the elected route, the primary route, which will be seen in the routing table of K. Now, whether to use this route as the backup route or not, whether to use this in the topology table or not. See this, even though there is a route, it may not be seen in the topology table sometimes. Why? It needs to satisfy something called feasibility condition. What is feasibility condition? Feasibility condition says this alternate path that you are trying, no? That alternate path's advertised distance must be less than the successor value. So, how can we write in our topology? Is 30 is 30 less than the successor value? What is successor value? 30. Is this alternate is that advertised distance of the alternate path is less than the successor value? If only yes, this will be seen in the topology table. Otherwise, it won't be seen in the topology table because dual algorithm will think that there is a loop. That's why it is higher. So that is what feasibility condition is. Feasibility condition is used by dual algorithm to pick a loop free alternate paths. So if this condition is not met, according to feasibility condition, according to dual algorithm, there may be a chance for loop, so it won't pick. In case if this is 9 here, this would have been 29. Now definitely 29 is lower than 30, so this will be seen in the topology table. This both root will be there in the topology table, but blue root will be only available in the routing table. So for feasible successor, the feasibility condition need to be met. What is the feasibility condition? Advertised distance should be less than the successor value. Please ask me question from here now. No questions?
Sir,
Ah.
you told that load balance will be occur, no?
Load balancing will happen only if variance is tuned. We have not spoken about variance, but yesterday I gave you introduction to variance. Unequal cost load balancing is possible only when you configure a feature called variance. By default, unequal cost load balancing is not supported. By default, it is not supported. You have to configure.
Okay, sir.
Only when you configure variance, this path that is there in the topology table can be seen also in the routing table to do packet forwarding. See, for packet to be forwarded, unless the route is there in the routing table, it won't forward. Route needs to be there in the routing table. For bringing the route to the routing table, the unequal cost path route into the routing table, we use variance and do that. That is manual configuration that we will see later. Any other question?
So what if the alternate path does not match the feasibility condition?
Then there won't be any alternate path in the topology table as a feasible successor.
Okay, so if the primary link goes down, then the network will be down in that way?
No. If the primary goes down, very good question now, but we are going to see these things later in detail. Now I am just explaining.
Okay.
When this is 10, the feasibility condition will not meet. No, it is 30 is not less than, advertised distance is not less than successor. So 30 is not less than 30 because it is not meeting the need. This will not be considered in the topology table. So there is only one route, primary route, no backup route. When something goes wrong here, there is a wire cut here. Now K will now cry to everyone. Everyone means not to B, to all other neighbor. He'll say, hey, do you know anything about the 7777? I lost the route. Do anyone knows that? And A will receive it and say, A will say, you want 777? No problem, I can take you. Take this metric. This is my metric. Advertised distance is 30. Take it. Then it will say, okay, I'll go via A now, which is 40. But it will be very slow in convergence. It won't happen immediately. It has to query, wait for the response, and then it will compare all the responses and pick one. Sometime it will get stuck in active for 3 minutes. We'll talk about that later. Let us not get into that. But answer to your question is, it will not be able to use the backup route because it is not readily available. It has to discover that there is another route. For that it will send queries, wait for the responses. Only based on the response it will find an alternate, find another primary path. It's no more, the previous primary is no more a primary. Now this is the only primary via A. So you cannot call it as an alternate path now, because that's the only primary. Okay, next question.
only the second best root will be in the topology table, no?
Second best route which satisfy the feasibility condition. That is what it means, best route. If it didn't satisfy the feasibility condition, it is not a best route. It is not even considered as a route. A K will not worry about think about that route because it didn't satisfy the feasibility condition. Dual algorithm will say, Naku boddu, naku oddu. I don't want that, I don't want that. So it won't be seen in the topology table. வேண்டாம் வேண்டாம் வேண்டவே வேண்டாம். இந்த டீயில் நிறம் இல்லை, நிறம் இருந்தால் சுவை இல்லை, சுவை இருந்தால் மனம் இல்லை. Fine then. See you tomorrow in the continuation class. Thanks for joining today. Take care.